we want to convert the following decimals into fractions. Here in this example, and the subsequent ones, we'll get much more difficult problems than those we've seen before, and that's because we now have recurring decimals. I'm going to look at two methods of doing this. The first is the method you'll find most often in textbooks. The second method, however, can be much easier than this first method, so I suggest you stick with the example and watch the second method. Let's look at 0.4 recurring. We let x be equal to 0.4 recurring. This is 0.444 and so on all the way to infinity. Now consider 10 times x, 10 times 0.4 recurring. This must be 4.4 recurring. Multiplying 0.4 recurring by 10 moves the decimal point one place to the right, giving us 4.4 recurring. Now consider 9x, which is 10x take away x. So 9x is 4.4 recurring take away 0.4 recurring, which is just 4. We're doing this number take away this number, so we lose the decimal expansion. And therefore x is equal to 4/9. So we can write that 0.4 recurring is equal to 4/9. Sticking with the first method, we have 0.45 recurring. Let x be equal to 0.45 recurring. Note how we have a dot over both the 4 and the 5. 0.45, 45, 45 and so on to infinity is this number. The dot indicates that both the 4 and the 5 recur. If we do 100x, this would be equal to 45.45 recurring. Timesing by 100 moves the decimal point 2 places, so we can see how this works. Now consider 99x, which is 100x take away x. That's going to be this number take away this number, which means we'll lose the decimal expansion, just getting 45. So x is going to be 45 over 99, and there's some cancelling here. 3 goes into 45 15 times, and into 99 33 times. So x is 15 over 33. Now let's consider the second method. For the second method, you need to remember that 1/9 is 0.1 recurring. 1 over 99 is equal to 0.01 recurring, with the dot over both the 0 and the 1. And 1 over 999 is equal to 0.001 recurring, with the dot over the first 0 and the 1. This means 0.001 001, 001, and so on to infinity. The dots on a recurrence pattern indicate the beginning and the end of the recurrence pattern. So with a dot over the first 0 and the 1, it means that 001 repeats until infinity. For 0.4 recurring, we can see that the recurrence pattern is just one digit long, 0.4444, and so on to infinity. If the pattern is one digit long, we use 1/9, since the recurrence pattern here, 0.1 recurring, is just one digit long. If 1/9 gives us 0.1 recurring, it stands to reason that 4/9 will give 0.4 recurring. Now let's look at this one. The recurrence pattern is 2 digits long, 45, 45, and so on. For this we'd use 1/99, since the pattern here is 2 digits long, 01, 01, 01, and so on. If 1/99 gives this, then 45/99 is going to give us this. So we have 45/99, which cancels to 15/33. Suppose we were dealing with 0.203, 203, and so on to infinity. The expansion pattern is 3 digits long, so we use 1/999. We get 203/999. If you look at this carefully, you'll see where the 203 came from. This second method requires you to remember 1/9 is 0.1 recurring, and so on. But as we'll see with some of the more complex examples, this method can be very much quicker.